So, so first, last lecture, suppose in last week we discussed about the potential and the potential difference. Uh, so in that case, there is a one application regarding with the line charge. Suppose that we have a line and this line is placed in the either x-axis or y-axis or z-axis, maybe in any coordinate system. Suppose that this way, so this line is placed in the z-axis coordinate system, and it must have some units, maybe +5 to -5, okay, or maybe plus infinity to minus infinity. And if a point is placed near to that charge line, okay, then we need to find the potential difference at this point. Because as you know that when we have a charge distribution, from this charge distribution, the electrical field lines are created. Okay, electrical field lines are created, and we have calculated the formula for the potential difference, that V is equals to minus E dot dl. So means the potential difference depends upon the electrical field intensity and the differential length. And suppose if I selecting the length at this position, so this is the length distance from the charge distribution to the point of interest, So see that the potential difference depends upon the electrical field intensity. Okay, how much electrical field intensity? As you know that, suppose if we have a charge and this positive charge creates the electrical field line. Okay, the electrical field lines will be diverged from this positive charge. So at this position, the intensity of electrical field is higher. At this position, the intensity is lower. The intensity of electrical field is lower at higher distances and higher at lower distances. Similar way, so we need to find the potential difference at this point. Suppose this is one the line, and from this line electrical fields line are created. I need to find the potential difference at this point. So how to find it? So first we need to define the length. This length, from the concept of cylindrical, we can say that this one is rho. This one is rho. So the electrical field can be calculated as rho L divided by 2 pi epsilon naught rho A rho cap, because the point is moving in the direction of rho vector. In the direction of rho vector, therefore it will be a rho, and this is the formula that we have calculated in your Coulomb's law application. If you recall the second application of a Coulomb's law, that if we have a finite line charge, if we have a finite or infinite line charge, then the electrical field is equals to rho L 2 pi epsilon rho into A rho. So in this case, from this formula we can easily find out the potential difference. If we know the value of E, then the potential difference can easily be calculated. Or maybe the potential is given. At this point the potential is some volts, maybe any voltage value is given. Then you can also calculate the electrical field by the reverse process. So maybe the point is placed here and it has a distance that is equals to rho B, and this distance is equals to rho A. You can find the potential difference from point A to point B, by using this formula: minus A to B to A rho L. This is the formula for the electrical field intensity. As you know that we have generally defined the formula, minus E dot dl. So E is divided by 2 pi epsilon rho into A rho. This was the value for the electrical field, dot dl, where dl is the differential length. So the differential length is moving in which direction? And moving in the rho direction. So this will be a d rho A rho cap. So the dot product of A rho will be 1. So the equation will looks like, so the dot product of A rho cap dot A rho cap is equals to 1. So we have to multiply by using dot operation here. So this will be 1. So only left is d rho. So d rho is here. So now I can easily make a integration, because the integration is with respect to rho. So the constant may be shifted to the other side. So rho L is constant divided by 2 pi epsilon. So it's limit from rho B to rho A, 1 over rho. So 1 over rho means rho minus d rho. So it will be easy. So it will be plus. So if I put the value minus rho L 2 pi epsilon ln of rho A minus rho B. So this is the formula. You know that the logarithmic property, that if the logarithmic has a minus value, that means it is divided. If it has a positive value, that means it is multiplied. So you can use the formula to find out the potential difference. So rho L divided by rho L is basically the line charge distribution, is the density. जो line है इसकी density कितनी है? Where 2 pi epsilon constant है, ln over rho A is basically distance from line to the point of interest, and rho B is also a distance from line to the point of interest. So you can easily find out. So in next slide, so this is the homework problem. Please check it and solve this problem by your own. And similar problem, the values are given. Okay, at point B, the potential difference is 0. This one is the lower voltage value, and this one is the higher voltage value. And these are the 2 points, 135, 257. So the rho B will be 1 and rho A will be 2. So you can use the limit formula and solve the equation for the potential difference. Is that clear?
Yes, sir.